Hi, my name is Durga Prasad from Vvit University of the registered number is 25BQ580409. Now we are talking about the moments from the probability theory and static process (PTSP). First of all, we go into the introduction of the moments. What are the moments? The moment is a numerical measure to describe the properties of probability distribution or a random variable. It is used to measure the describing properties like shape, spread, and location of the signal, and shape of the signal, and how the spread of the signal, and what is the location of the signal. Think the moments as statistical fingerprints that is summarize the data. Why do you use the moments? To summarize the important features of a random variable and to describe central tendency or average behavior of the signal, and the moments is gives describe spread and dispersion or data variation. That means how they disperse the signal, and it gives shape of the signal like this or like this or like this. What is the shape of the signal? And it provides the tools to compare the different distributions. This is the use of the moments. Now we are going to the next slide, the types of the moments. We have two types of the moment. First one is moments about the origin and moments about the mean. That means the moments about the origin. That this is a given Gaussian given signal, and this is x-axis, y-axis, and this is x-axis. Moments about the origin means the moment at the origin, 0 point, 0 comma 0, and the moments about the mean means central moments are mean position. This is two types of the moments, and we are going to the first moments about the origin. The moment about the origin, expected value of x power n. That means the moments of the origin is denoted as a mn. It's the second element of the origin. It is denoted as a mn. N is in x power n. We have a different types of n values. The zeroth moment, n is equal to 0. If n equal to 0, then m not equal to 1. That means the formula have minus infinity to infinity x power n into f of x into dx. If n equal to 0, it gives the area under the PDF, probability distribution function. That means m not equal to n equal to 0, mn equal to 1. The first moment, that means mn equal to 1. If mn equal to 1, the m1 equal to e of x equal to mean. That means it gives mean value of average value. Equal to m1 equal to mn equal to 1. That means n equal to 1. And second moment, that means n equal to 2. The mn is equal to e power s square equal to mean square value. The x, e power x is also known as mean. E power s square equal to mean square value. If the root is applied to the m2, it gives root mean square value. That means RMS value. This is all about the moments about the origin. and it denoted as the formula is minus infinity to infinity x into f of x into dx. F x of x. If x power n. If n value equal to 0, it gives area under the 1, area under the PDF. If n value equal to 1, if n value equal to 1, it gives mean value. If n value equal to 2, it gives mean square value. This is all about the moments about the origin. Central. Now we are going to central moments. Moments about the mean. The formula is expected value v of x equal to x bar x minus x bar whole x bar whole power n. Now it is denoted as a mu n. You measure deviation from the mean. The continuous case mu n equal to e power x minus mu or x bar whole power n is equal to integration of x minus x bar or mu whole power n into f of x into dx. Now we have a n values n equal to 1 or 0 or 2. If n value equal to 1, 0. if n value equal to 0, it gives 1 or area under the PDF or valued probability. In moments about the origin, it gives mn equal to 0. In central moment, mu n equal to 1. If n equal to 0. Now, if mu n equal to 1, it gives the 0. Mu of n equal to 0. The property mean deviation cancel out, and positive negative deviation, the sum is 0. We have formula for this. N equal to 1 to infinity x minus x bar whole power n into f of x into dx. X of x into dx. We have a formula like this. If the important from central moment, if mu not equal to 0, it gives 1. That means area under the period. If mu 1 equal to 0, it gives deviation cancel. That means 0. If mu 2 equal to 0, it gives variance. The variance about the curve. If mu 3 equal to 3, it gives skewness. If mu 4 equal to 4. If mu 1 equal to 4, it gives Kurtosis. The n values based on the n values. These are our n values 1, 0, 2, 3, 4. The central of the moment summary table is n equal to 0, value distribution. N equal to 1, 0 deviation balance. If n equal to 2, variance. That means variance means delta of x square or variance. The square root of variance is gives standard deviation. That means that's a lambda x sigma x equal to square root of e of x minus x bar whole square. This is standard deviation. And if you quantitative, you will not discuss about the quantitative, the variance. We are talking about the variance. Variance measures the deviation from the mean. It is a second central moment. That means n equal to 0, mu 2. The small variance gives data close to the mean. So this is the signal and this is the mean point. If the variance is low, that means variance equal to low. This is like waveform is like this, close to the mean point. If variance equal to large, the data is spread out like this. If variance equal to close to the mean, if variance equal spread is large to the mean, spread to the mean. The variance is spread of the signal. A continuous mu t equal to e power x minus x is the formula for the variance. Now square root of the deviation. Why square the deviation? That means sum of the x minus x bar or mu is equal to 0, mu 1 equal to 0. Squaring ensures the positive values and it provides the meaningful measure of a spread. That means discrete lambda square is equal to sigma of xi minus mu of s square into p of xi. Now we are talking about the standard deviation. The square root of the variance. That means lambda x is equal to square root of variance. Variance equal to e power x minus x bar whole square. Use the same units of a original values. The standard deviation is more interpretable than this. Give more interpretable than the variance, which you use the square root unit. The standard deviation gives the deviation of the signal. How the signal is deviates. And the variance gives the near to the mean or away from the mean. We have a standard deviation variance are talking about that. Now we are talking about the it is complete notes about the moments in probability theory and statistics.